The topic of my lecture today is 6G communications and sensing using THz radiation. This topic is not without a controversy, because many people feel that even not fully yet deployed 5G communications are quite sufficient and maybe too much, and they could actually do without it. However, in my lecture, I will show that 6G communications is not only unavoidable, but will actually change our lives in many ways, enabling a host of different applications. However, these two pictures, generated by Microsoft Copilot, they kind of have a support the skeptical view. One of them shows a modern classroom where many students, if not all, are looking at their smartphones, sometimes even the instructor. And the picture on the right shows what is often referred to as digital dementia. In any case, this is the outline of my lecture. I will start from motivation. Why suggest communication? I will talk about using silicon very large-scale integrated circuits for the 6G communications photonics. Talk about new counterintuitive physics of modern optoelectronic circuits. Discuss THz circuit design, THz for THz detection and generation, line of sight detection for 6G communication, followed by conclusions. Well, let's start from motivation. This graph shows global mobile traffic as a function of year, and we see that in the year 2028, even 5G capacity fully deployed, and we have not reached it by, there's a big gap between what we have today in 5G and what it could achieve, will not be longer enough to handle the global traffic. So we come to a conclusion that indeed we need 6G communication. And once enabled, once deployed, it would have a huge impact. First and foremost, maybe for how we use our smartphones. And now, as you see from this chart, there are almost 7 billion smartphones in use, which is impressive, given that there are only 9 billion people on planet Earth. But in addition to 3D smartphones, 3D teleconferences, smart robotics, real-time control with feedback, enabling, for example, driverless driving, real-time medical imaging, real-time smart agriculture, working at home in a completely new environment, very different from what we have today, Internet of Things, and all that will be supported with high reliability communications and defense. And another important application, maybe crucial, is defense and homeland security. So this chart shows comparison between 4G versus 5G and 6G. And we see that 6G is actually orders of magnitude better and has orders of magnitude larger capacity for transferring data. And the 6G will require sub-terahertz to terahertz photonics. And the interest in terahertz photonics started in the beginning of the 21st century, peaked at the beginning of the 21st century, and then it somewhat declined, but now it's on the rise again. And this shows that lots of companies are interested in efforts in terahertz communication. And two countries are among countries investing heavily in 6G communication. China, that recently launched the first 6G satellite, world's first, and Russia. And applications range from communications in space, where communication range could reach thousands and thousands of kilometers, to applications in terrestrial environment, where the range is very limited by absorption of sub-terahertz or terahertz radiation in the atmosphere. But there are certain windows, among which the 200 to 300 gigahertz is the most important range for 6G communications. It will involve photonics, both broadband and line of sight. And this is what I'm going to discuss in this lecture.